In this demonstration, we're going to see Faraday's law in action. I'm going to show you how to generate a magnetic current in this coil of wire. No batteries anywhere. You'll have to believe me, but if you look around, there's no sign of any batteries. All I have is a coil of wire here. This is just a plastic base. And there's a meter there. If you watch the meter, when I take this magnet and fling it through the coil, watch the meter. You can see that when I fling the magnet through the coil, the meter jumps because there's a current induced by Faraday's law. Faraday's law tells us there's a current induced in the wire when the magnetic flux through the coil changes as I throw the magnet through. So let's convince ourselves that the current flows when the magnetic field is changing. I'm going to do that by stopping the magnet halfway through. So watch the needle. The needle jumps. But now it's completely stationary. No current is flowing. There's a pretty strong magnetic field through here because I've got the bar magnet right in the middle. But no current is flowing. Now if I go do the second half, the needle jumps again. And let's watch the direction of the jump. When I send the magnet in halfway, the needle jumps to the right. When I take it out, the needle jumps to the left. So the needle jumps one direction as the magnetic flux is through the wire, through the coil. The needle jumps one direction as the magnetic flux through the coil is increasing. And then when the flux decreases, it jumps the other way. And if I turn the magnet around, so I've got the north pole going in first instead of the south pole the way I had before, this time it'll be the opposite. Flux increases, but this time in the other direction. Needle jumped left, and now the needle jumps right. And if you watch very closely, when I do what I was doing originally, which is throwing the magnet all the way through, you'll see the needle jumps first one way, then the other very quickly. And that's because the magnetic flux first increased and then decreased very quickly. Let me do that again. So the needle jumps first one way, then the other way. Now if I do it more slowly, first one way, then the other way. First one way, then the other way. Or if I send it back, first the other way, and then the one way. Now let's see what happens if I go more slowly. So if I go very, very, very slowly, very slowly, very slowly, the needle hardly moves at all. I'm not sure if you could see any motion. There's a tiny bit of motion. That's because the magnetic flux was changing very slowly, and what drives the current is d flux d time. And if I make the flux change slowly, d flux d time is small, the needle moves only a tiny bit one way and a tiny bit the other way. Okay, let's do an in-between speed. Not as slow as that, but not as fast as before. So here we go. Needle moves a little bit to the left and a little bit to the right. And now let me do it the way I was doing it before, as fast as I can safely do it. And the needle moves much more. When I do it fast, the needle moves a lot. When I do it slowly, the needle moves in the same direction, but much less than before. So this is Faraday's law in action. When I change the magnetic flux through a coil, I generate a current in the coil. No batteries involved.